If you take a sample of water from pretty much any ocean in the world and look at it under the microscope, you'll see plankton. Plankton are free-floating microscopic creatures which form the basis of the ocean's ecosystems. However, a large proportion of these plankton are what are known as y-larvae. Obviously larvae grow into an adult form, but for over 100 years now zoologists have puzzled over what the adult form of y-larvae actually looks like. We do not know. This is weird when you consider that y-larvae can be found all over the world and actually form quite a large part of the ecosystem, and we still don't know what they actually are. So what are y-larvae? The y-larvae are also known as facetotecta, which is Latin for faceted roof, and that's because of the appearance of their heads. They look like they're wearing helmets. In fact, they look a bit like the alien from the Alien franchise. It's really weird. We still don't know what y-larvae actually are, but all the clues, which I'll talk to you about later, lead zoologists to believe that the y-larvae belong to a group of animals which are so bizarre that they require an explanation all for themselves. This group of animals is called Thecostraca, and the most visible group, by which I mean ones you don't need a microscope to look at, are called the Cirripedia, which is Latin for curl-footed. And that's because Cirripedia are barnacles which have little feelers which they used for feeding called cirri, which again means curls. The Cirripedia also includes a parasitic group called Rhizocephala, and these are even stranger. They're barely recognisable as animals. Rhizocephala is of course Greek for root-headed because they don't have a carapace, they instead have loads and loads of roots that infiltrate the host. It's horrible. Now barnacles, and actually Cirripedia in general, are one of those groups of animals where they're so strange we didn't actually know what they really were until relatively recently. In the Middle Ages, people used to think that barnacles were a kind of larval form of geese, as in birds. That's because they'd find bits of driftwood with barnacles growing on them, and they'd think, oh, what, barnacles look a bit like geese, well, the head that is. And we don't know where geese go during the winter, so there must be some trees somewhere in the north, on some island somewhere, which we've not discovered yet, who knows. And with the barnacles on these trees sort of unfold and become geese and then fly to where we live. And then some of the barnacles don't grow into geese and they fall onto the floor and they get washed away and we find them in the beach. So barnacles are a kind of weird larval form of geese. Of course we know this is rubbish. We know that the reason that you don't find any geese during the winter is because of migration, which was not known to people in those times. Now, this myth of the goose tree was well and truly vanquished when a zoologist discovered the life cycle of barnacles. The life cycle of the barnacles works like this. First, you have the nucleus, and that floats about growing and eating for months and months and months. This eventually becomes the cypress, and the cypress is the form that then settles to the bottom of the sea and looks for somewhere to live. Once it's done that, it can then become the adult form. John Vaughan Thompson recognised that because barnacles have the nucleus form, they're crustaceans, and because they have the cyprid form, that must mean they're in the Cirripedia group. We go back to the group of parasitic cirripedians, the Rhizocephala. Their life cycle has only recently been understood. They have an extra stage called a vermigon, and this is sort of a transparent tube of gunk. The vermigon is injected by the cyprid into the host where it can then grow into the adult parasites. It's bizarre, it's possibly the strangest thing in the animal kingdom. Back to the y-larvae then. What do we know about them? The y-larvae, because they have a nucleus form and a cyprid form, they must be related to Cirripedia. Maybe they're a sister group, or possibly they're in the group themselves. No one yet has managed to get the cyprid form to grow into its adult form. That's why we don't know what y-larvae actually are. Glenn et al. Captured some y-larvae from around the waters of Japan, and they introduced to the cyprid form a hormone called 20-hydroxyecdysone. Now, this hormone is usually used to make the larvae of crustacea grow to the next stage. And what happened in this case surprised everyone involved. Emerging from the cyprid case was a vermigon. They mixed the term y-larvae with vermigon to form the term ipsigon. The ipsigon shows that y-larvae are endoparasites. However, we do not know what they're parasites of. We don't know where to look really, but at least it's some way to solving the mystery of what the adult form actually is.